Hi everyone, today we're going to start our new unit, Unit 8, over exponential functions, and today we're going to learn how to graph them. So the exponential function equation is f of x, remember it's the same thing as y, equals a times b raised to the x. So we know this is an exponential equation because in the exponent we have our variable. So we're given these three different graphs and we want to find information about each of them. So this first graph, f of x equals 3 raised to the x. So our first question, is this increasing or decreasing? So read it from left to right, just like how you read a book. Is this going up or is it going down? It is going up. So this would be increasing. The y-intercept, remember the y-intercept's where it crosses the y-axis, the vertical axis, so right here at 1. So when we write the y-intercept, we write it as an ordered pair, 0, 1. Now here's a new word for the day, asymptote, okay? And so we're going to go over to this box over here to define our new word. The asymptote is a line that the graph approaches but never touches. Okay, I like to think of it like an electric fence. Okay, get really close. It's going to get really close to touching that line, but it's actually never going to pass it. And it's always a y equals equation. So if it's a y equals equation, it's always going to be a horizontal line because we know y equals equations always make a horizontal line. So it's always going to be at the bottom where this starts to flatten off. So this does flatten off, and it doesn't ever cross wherever, depending on which graph, wherever it's stopping. So it's going to keep going to the left, but it's not going to keep going down. It's going to it's getting really close to 0. So 0.01, 0.0001, and so on. So our asymptote is going to be y equals 0 because that is where it starts to flatten off. All right, domain and range. Remember, domain, we read from left to right, and it's our x function. So to the left, there's an arrow. To the right, there's an arrow. So we're going to say all real numbers. Remember that fancy R. And then the range of the function we read from bottom to top. So this is where the asymptote is going to come in. We do have a bottom of this graph because it's stopping at that asymptote, at that electric fence. So the graph is above 0. So if it's above 0, I'm going to say y is greater than 0. And with our parabolas, with our quadratic functions last unit, we would put the line underneath it. But with that asymptote, it's never actually going to touch that line. So we're not going to put the or equal to underneath the inequality because that would show that it's touching and it never touches that asymptote. All right, let's see what happens with our next graph. G of x equals 2 times 3 raised to the x. So this time, let's see, increasing or decreasing. It's still increasing. The y-intercept where it touches the y-axis is right here at 2. So we'll write that as 0, 2. Now for the asymptote, where does it start flattening off? It again starts flattening off at the x-axis. So if I drew this dotted line right here, it would be again, if you look at the y-axis, at 0. So our asymptote for the second one is y equals 0. Again, the domain of this function, arrow to the left, arrow to the right. So we say all real numbers. And the range of this function, so again, our asymptote is at 0 and the graph is above. So we'll say that the range is, again, y is greater than 0. All right, our last graph up here is h of x equals 3 to the x plus 2. So the difference here is that now we're adding 2. So our graph, it looks like it moved up. So is it still increasing or is it decreasing? Still increasing. Our y-intercept moved to 0, 3. Our asymptote, all right, so here it's flattening off right here. So if I drew that dotted line right here, where would I hit on the y-axis? At 2. So the asymptote will be y equals 2. Domain, left to right, I see arrows both ways. And for the range, my graph is above my asymptote still, so I am going to have a greater than again. But what is it greater than? Is it still greater than 0? That's too low, right? We want to say whatever our asymptote is. This will always be the same as the asymptote. So this time it's going to be y is greater than 2. All right, 2 says predict what would happen if you graphed y equals -3 to the x. Graph the equation and describe the effect of a negative value for a. Is the function increasing or decreasing? So what do you think? Go ahead and jot down. What do you think the negative in front of the 3 is going to do? I'll go ahead and put it in my calculator for us. So in y equals, I'm going to put -3. Then I'm going to use this caret to put the x in the exponent. Now when I press graph, it has that flat part and then it's going down. So that negative right there made it decrease. So now my graph is decreasing. And we can say when we talked about transformations with our quadratics, we learned about reflecting. So it reflected over the x-axis, just like our parabola did when our a was negative in that equation when we did transformations. All right, so here are the different parts to the exponential function. So we're starting off with our x. Our variable is always in our exponent. That's what makes it exponential. Our b is our multiplier. That's what makes it increase rapidly or slower. And then our a is our y-intercept. So we'll go through this more with the upcoming notes. But when b is greater than 1, okay, so the number that has the x on the exponent, it's exponential growth. Okay, so it's increasing. When b is a fraction, so between 0 and 1, then there is exponential decay. So that means it's decreasing, going down. And then like we just said, if a is negative, that made it decrease and it reflected over the x-axis. And you'll see that a little bit today with these last 3 questions, but when we start to interpret the exponential functions, the next notes, these will make more sense as well. All right, number 3, the graph of an exponential function is shown on the grid. Based on the graph, which statement about the function is true? So if I'm reading my answer choices, I see they're all asking about domain and range. So I know that domain, I read from left to right. And I see there's an arrow going to the left, an arrow going to the right. So just like the ones on my front of my page, the domain is all real numbers. So I can cross off B and D because they say the domain is all real numbers greater than -4 or less than -4. All right, range. I know that is bottom to top. And I can look at my asymptote, that new word that we learned today. This is where it's flattening off. So if I draw my asymptote, it's going to be at y equals 0. So is your graph, it says the range is less than 0 or greater than 0. My graph is above my asymptote line. So would that be less than or greater than? Greater than. So your answer is C. Number 4, which dashed line shows the asymptote of this graph? We know that asymptotes are always y equals and are always horizontal. Those go hand in hand. So which two can we automatically cross off because they're not horizontal lines? Q and R. So for S and T, they're both horizontal lines, but the asymptote, it has to be approaching that line. It has to be really, really, really close to our electric fence. Okay, so which one would show that, S or T? It's going to be S. T is too far. It's not approaching, the graph isn't approaching T, it's approaching S. All right, our last one, number 5. Which statement about the graph y equals 1/3 times 2/3 x is true? So now I'm given an equation, but I'm not given a graph. So that means I'll use my calculator this time and plug this in. So remember, to get a fraction, we do alpha y equals, enter. So I'll do 1/3, parenthesis, alpha y equals, enter, 2/3, raised to the x. Then I'll press graph. All right, so on my notes, I'm going to sketch what this looks like. So if I need to look back at my notes, I know what it looked like. So A says the graph has a vertical asymptote, but we know over here that asymptotes are always horizontal. So it can't be A. The graph crosses the y-axis at 0, 2/9. All right, let's look back at our graph. Could be, right? Let's keep looking. The graph has an asymptote at y equals 1/3, and the graph decreases from left to right. All right, so the graph decreases. Is it going down from left to right? Yes. All right. But let's check to see if these other ones are true. So if I go to the table, we can kind of see these points better. So it's saying 0, 2/9. I see 0, 1/3. So B is not right. It should be 1/3. So now when C says the asymptote is y equals 1/3, the asymptote, it never crosses the asymptote. So if the y-intercept is 1/3, the asymptote cannot be 1/3 because that's what it approaches but never touches. All right, I hope you have learned how to graph exponentials. When you're in doubt and just given an equation, always put it into y equals so you can see what the graph looks like.